is case study 12 for Pensacola Surgery Center's time value analysis. Consider the $500,000 excess cash and assume that Gary invests the funds in a 1-year CD. We want to know what the CD's value at maturity will be if it pays 10% annual interest. And it also wants to know what will its future value be if the CD pays 5% interest, and then if it pays 15% interest. So on the left, we start out with a 1-year CD at 10%. We have the present value of $50,000, our rate's 10% for 1 year. We find the future value is $55,000. Now in the middle, we have 5% with the same present value, but the rate's changed and it's still at 1 year. We get the future value is $52,500. The 1-year CD at 15% with the same present value for 1 year is $57,500. For number 2, it wants us to rework parts A through B of question 1, assuming that each CD now has a 5-year maturity instead of 1 year. So we go through, and on the left, we started out at a 10% with the same present value of $50,000, but now we have 5 years instead of 1. And we get a future value of $80,525.50. A 5-year CD at 5% rate for 5 years is going to be $63,814.08. 5-year CD at 15% is $100,567.86. Now consider the surgery center's goal of having $200,000 available in 5 years to buy a new patient billing system. What lump sum amount must be invested today in a CD paying 10% annual interest to accumulate our needed $200,000 goal? So if we do the lump sum down here on the left, we have our future value, our goal of $200,000. We want to reach that goal in 5 years at a rate of 10%. We know that right now we have to invest $124,184.26. For B, what annual interest rate is needed to produce $200,000 after 5 years if we only invest $100,000 right now? So this, we invest, our present value is going to be $100,000. That's how much we put down now to reach our goal of $200,000 in 5 years, and we find that we have to have an interest rate of 14.87 cents to reach that goal. Now consider a second alternative for accumulating funds to buy the new billing system. In lieu of a lump sum investment, assume that 5 annual payments of $32,000 are made at the end of each year. We want to know, first off, what type of annuity is this? And we know that it's an ordinary annuity because the payments are being made at the end of each year. For B, we want to know what the present value of this annuity is if the opportunity rate is 10% annually, and then again, if it's semi-annually. So for the annual one, we have a payment of $32,000 that we're going to be making at the end of each year for a period of 5 years. And on this one, we're just going to use the stated rate of 10%. The compounding should be at 1. That was my mistake on here. But we solve for the present value, and we find that we get the present value of the payments would be $121,305.18. If we do it so it's semi-annually, we're now going to use an EAR rate of 10.25%, and the EAR is the effective annual rate. And we know that this is the interest rate under annual compounding that produces the same future value that was produced by more frequent compounding. So we're going to use this number instead of the 10% because we're compounding. And so we plug that in as the rate, and we find the present value is now $120,534.40. What is the future value of this annuity if the payments are invested in an account that pays 10% interest annually, and if it pays 10% compounded semi-annually? So annually, we're going to do the same thing we did on the last slide, except for now we're looking for the future value. So here we have a payment of $32,000 with the stated rate of 10% for 5 years. It's only being compounded once annually. And when the future value of these payments are going to be $595,363.20. if we do it semi-annually, we're going to use our effective annual rate of 10.25% again, because we're compounding twice with our payments of $32,000 for 5 years, and we get a future value of $196,337.83. For D, it wants to know the annual interest rate that's required in order to reach the $200,000 that's needed to make the purchase, if we're still assuming the $32,000 payment. So our payment is still $32,000. Our future value we want is $200,000 in 5 years. The rate that we would need would be 11.18%. What size annual payment is needed to accumulate $200,000 under annual compounding at 10% interest rate? We have the future value of $200,000. Our rate is 10%. We're going to be doing the payment function, and we find out that we need to make payments of $32,759.50 at a 10% rate for 5 years to reach our goal. Now consider the uneven cash flow stream stemming from the lease agreement given in the case. We want to know the present value of the annual lease cash flow if the opportunity cost rate is 10%. So we have these all listed, and our rate's 10%. We want to know the net present value of how much these are, and we find that that number is $47,328.61. Now, does the office renovation and subsequent lease agreement appear to be a good investment for the company? Our renovation cost we know is $40,000. The net present value for the lease agreement was $47,328.61. If we subtract $40,000 from the renovation costs from the NPV, we find that the return on their interest is $7,328.61, and that their rate of return was 16.39. So yes, this would be a good investment because it results in a return on their investment of $7,000, and the rate of return is 6% greater than the opportunity cost rate of 10%. For 7, it wants us to assume that it's been 5 years and the company is still unable to accumulate $200,000 that they need to make the software purchase. So instead, they decide to borrow the money, and the loan calls for a repayment in equal annual installments over a 4-year period, with the first payment due at the end of 1 year. Assuming that the company can borrow the funds at a 10% rate, what amount of interest and principal will be repaid at the end of each loan? So here we need to find our payment amount first, and so we have our present value of $200,000 in a 4-year loan for the NPER at a rate of 10%, and we find that the payment they need to make each year is $63,094.16. So here at year 1, we have a beginning amount of $200,000. Their payment that's due is the $63,094, and then for the interest, they're going to take their 10% and multiply it by the beginning amount of year 1, which is $200,000, and get $20,000 for interest. Principal is going to be found by subtracting the interest amount from the payment amount, and it gives you $43,094.16. The remaining balance, or what is left to be owed, would be your beginning amount of $200,000 minus your principal amount of $43,000, and it leaves you with $156,905.84. This remaining balance is now the beginning balance for year 2. And you'll go through and do the same setup of bringing down your payment, which is the same amount. Your interest is now 10% times the beginning amount for year 2. The principal is still the interest subtracted off of the payment amount, and the remaining balance is still your beginning amount for year 2, $156,905.84, and subtracting the principal off of that to get $109,502. You continue to do this for year 3 and year 4, and in year 4 we see that the payment is still $63,000, even though they only owe $57,358. So they will have some left over, but it still reaches zero. And we total up the interest amount, and we get that they paid a total of $52,376.64 in interest, as well as the principal amount of $200,000.